In the freezing winters of the European theatre or the damp jungles of the Pacific, a simple column of smoke was a death sentence. If you lit a standard campfire to boil water or warm your hands, the rising plume acted as a beacon for enemy artillery, and mortar fire usually followed within minutes. Yet soldiers needed heat to stave off hypothermia and hot water to sterilize their gear. The solution was an ancient technique refined by necessity, known today as the Dakota Fire Hole. This method allowed a fire to burn incredibly hot, consume minimal fuel, and, most importantly, produce almost no visible smoke or light signature. Before we break down the physics and the exact construction method of this survival staple, make sure you subscribe to Atten Recounts right now for more deep dives into the tactical history that shaped our world. This knowledge isn't just trivia. It is the difference between life and death in the field. The physics of the draft creates a smokeless engine in the ground. The genius of the Dakota Fire Hole lies in how it manipulates airflow to achieve near-complete combustion. Smoke is, essentially unburnt fuel particles escaping because the fire isn't hot enough to burn them. A standard surface fire wastes heat and scatters smoke because the oxygen supply is, erratic. The Dakota Fire Hole changes this dynamic by placing the fire chamber underground and feeding it oxygen through a dedicated intake tunnel. As the fire burns in the main chamber, the rising heat creates a vacuum effect that sucks cold, dense air down the intake hole. This concentrated blast of oxygen hits the base of the fire like a blacksmith's bellows. The result is a fire that burns so intensely that it consumes the particulate matter that would usually become smoke. You are left with a high-heat, low-visibility heat source that remains hidden below the surface of the earth. Constructing the chamber requires precise measurements and soil selection. To build this yourself, you must first assess the soil conditions because loose sand will collapse while wet clay will require significant effort. You start by digging the fire chamber, which should be a plug roughly 1 foot in diameter and 1 foot deep. The walls must be vertical, not sloping to contain the heat effectively. Once the main pit is cleared, you move about 1 foot away from the edge of the fire pit to dig the air intake. This second hole needs to be slightly smaller, perhaps 6 inches in diameter, and angled down toward the bottom of the main fire chamber. The critical step is connecting them. You must tunnel from the bottom of the intake hole through to the base of the fire chamber. When you're finished, you should be able to see daylight through the tunnel when looking down the intake. This U-shaped distinct structure is what separates an amateur pit from a tactical heat source. Fuel efficiency makes this technique vital for evasion and scarcity situations. Once the structure is built, the way you manage fuel changes compared to a traditional campfire. Because the heat is trapped in the earth, the Dakota Fire Hole requires significantly less wood to cook a meal or boil water. You do not dump logs into the hole. Instead, you build a small platform of sticks at the bottom to ensure airflow remains unobstructed, then feed larger sticks vertically into the pit. The fire burns the wood from the bottom up. As the bottom of the stick is consumed, gravity drops the unburnt fuel into the sweet spot of the heat. This efficiency was paramount for soldiers who could not risk the noise of chopping down trees or the exposure of scavenging for large logs. A handful of dry twigs could boil a canteen cup of water in minutes, allowing a unit to heat rations and move out before the enemy could detect a thermal signature. These days, modern survivalists use this method to evade detection and, well, cope with the wind. Beyond the battlefield, this technique has become a cornerstone for folks like modern survivalists and stealth campers, especially those operating in high-wind environments. You see, a surface fire is easily extinguished or spread uncontrollably by a strong gust, but the Dakota Fire Hole protects the flame inside the earth. If you are camping on a windy ridge or, out on the open plains, this method ensures you can cook a meal without fighting the elements. To cook, you simply bridge the top of the fire chamber with green sticks or flat rocks and place your pot directly over the heat. The earth acts as an insulator, directing all the thermal energy upward into your cookware rather than losing it to the surrounding air. When you are finished, the evidence is easily erased. You push the dirt back into the holes, replace the sod cap you carefully removed at the start, and scatter leaves over the site. Within minutes, the ground looks undisturbed, leaving no trace of your presence. The Dakota Fire Hole is a prime example of how tactical necessity drives innovation. It proves that the most effective survival tools are often knowledge, not gear. By controlling the physics of combustion, you can stay warm and fed while remaining invisible to those who might wish you harm. If you found this deep dive into military survival history valuable, share this video with a fellow enthusiast who appreciates the technical side of history. And, do subscribe to Atten Recounts for more insights into the strategies that defined the past.